party to go to.
Can I come?
Yeah. Okay, so let's get to studying.
Oh, okay.
Alright? So, I came to you because you're like the smartest one in our class.
Wow, that's an honor. Really coming from you, Peyton? You're just the prettiest girl in school.
Well, thanks.
Okay, Peyton. So I heard you came to me because you want to learn the 3 laws of motion. Newton's 3 laws of motion.
Yes, I did, Kendall.
Wow, today I've got a lot in store for you today. I mean, you're just going to be like an expert. You're going to be like a science nerd like me after today.
Yeah, alright.
Okay, let's get started. Okay, so let's start with numero uno. That means number 1.
What language is that?
French. Okay, Newton's first law states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force.
English, please. I'm not in French anymore.
Oh gosh, I knew this would happen. I have demonstrations for you. So you see here, Peyton, it's a volleyball.
Well, of course, I'm not stupid.
Sure you aren't. Anyway, the volleyball is not moving at this moment. But you see, when I go, it moved, because I am the external force that moves the volleyball.
Wow, you're really smart.
Okay, now let's move on to inertia. Because of inertia, a body at rest remains at rest, and the body in motion continues moving in a straight line at a constant speed unless a force is applied to it. Mass can also be considered a measure of a body's inertia. Now another thing you need to know about Newton's first law is what momentum is. Momentum is the product of mass and velocity.
Can you give me an example? Because
Yes, first the formula of momentum is mass times velocity. So if a truck and a car were both going downhill at the same time, the truck would gain more momentum and get to the bottom of the hill first because it has more mass than the car.
Really?
Yes.
Oh, I have a truck.
Cool, maybe you can test this out sometime.
Yeah, maybe.
Now we are on to Newton's second law. Newton's second law says that acceleration is produced when a force acts on a mass. The greater the mass, the greater force needed. In a vacuum, all objects have the same acceleration since there is no air resistance in a vacuum. Normally, because of air resistance, a feather would take longer to fall than a rock. But because there is no air resistance in a vacuum, if they were dropped at the same time, they would fall at the same time.
Yeah.
The law also states that the acceleration and the speed of the object depends on the net force.
This is so much to just soak up. You know,
Okay.
I don't know if
I'll try to make it easier for you.
Alright.
What that's trying to say is, say you had a wheelbarrow full of gravel. It would be easier for an adult to push that wheelbarrow than it would be for a toddler to push that wheelbarrow.
What's an adult?
Someone over the age of 18 years old.
It's gonna be me in a few years.
Yes. Okay, anyways, that's also saying that it would be easier for a person to push an empty wheelbarrow than it would be for them to push the wheelbarrow full of gravel.
So I don't really understand this yet. Can you go further into your information?
Yes, I shall give you another example. So say 2 trains were coming at each other at the same force and speed. When they hit each other, they will both feel the same force and go the same distance. But if, say, one train had another train attached to it, when it hits the single train, the single train will go double the distance and feel twice the force.
Okay, I get it. Yeah.
What's that?
What was that? Do you have like a dog or something?
No, my parents are out at bingo. We don't have a dog.
Bingo. Okay, this is really freaking me out.
Oh, whatever. Let's just keep going. Probably nothing.
The wind, maybe? Do you see that? The doorknob. Do you want to go up and check, or?
No. We need to finish.
Okay, that was really weird, but let's just forget about it and keep going.
Oh yes, keep on studying. Alright, now we are on Newton's third and final law, which declares for every action there is an equal and opposite reaction.
Okay. Yeah.
Okay, I shall give you some demonstrations. The first example is the rocket ship. The rocket's action is to push down on the ground with the force of its powerful engines, and the reaction is that the ground pushes the rocket upwards with an equal force.
Thanks, Kendall.
Alright, now for the second demonstration of Newton's third law. Could you please stand up on my bed and start to jump?
Me? Stand up?
Yes.
Alright, I can do that.
Okay,
What does this show me?
Stop. So when you jump, you exert a force into the bed, and then the bed exerts a force on you, which causes you to move upwards to the sky.
So, technically, I'm part of this. I'm scientific.
Yes, you are.
Oh my gosh. Okay, maybe it was just a power outage.
I know.
Positive.
Whoa. The door is
Oh
open.
god, okay.
We need to get out of here. This is too much.
What's going on?
Oh my gosh.
Kendall, what was that noise?
I don't know. I really just think we should get out of here.
I don't like this.
I don't either.
I came here all this way for this.
Yeah, you did. Oh my gosh. Okay, let me go upstairs and get something.
Oh my god! Oh my god! Oh my god! Go! Kendall, where are we?
I don't know, I'm lost.
We should be studying right now. I have a test.
Don't worry about your test. There's a live or death matter right here.
This is stressing me out. This is not good for me. What was that? Kendall? Oh my god! We got her good.
We sure did.